Welcome to Ymt218 Object-Oriented Programming. Today we are discussing inheritance. We've done with classes in the previous chapter, and today we will discuss a bit more advanced in classes, which is inheritance. So I'll speak about inheritance in general, then we'll speak about polymorphism, which is a special topic in inheritance. The idea of inheritance itself is available in our reality. I mean, it's not something that we are not aware of, but when we speak in a technical background, especially in programming, we speak about specific things, not just the inheritance that we know in our reality. However, we can use our reality to resample some examples and explain about them or use them as our illustration examples. Now, I'll just give a simple example about your own lifestyle as a student, those who are with me in the course. Now, you guys are students, and being a student is actually a generalized category or a generalized class. Being a student is just being an instance of a class, which is student. Maybe employee like us, being an instance of employee class. And the same goes to many other categories. Now, student, if we customize a class called student, and maybe we can set up some private attributes like the name, number, whatever, maybe GPA, all these private attributes, whatever the program or the problem requires, we set them up. Then we also create some methods like getters and setters. Then next to that, what happens? Now we have a general definition of a class. Why general? Because a student may be a university student, right? Maybe high school student, maybe primary school student, maybe some private student for some course or some research. These are different types of the same class. However, with some customization, some speciality. So we have the general class student, then we customize it or create a special class out of it. So this is the idea. We have a generalized class where we can extend it to a special class, and then we can create what we call actually is a relationship, and I'll explain about it in a while. So we can create a class student, and then we can create university student special class out of it that takes all the private attributes, also can have its own extra attributes. Maybe high school students also takes all the attributes of student and then adds to itself some other attributes, and so on. Now, for example, here we have like a class insect. It could be a class with the basic characteristics or attributes of insects in general. Then you may categorize. You just think about the insect that you want to address. Grasshopper, for example, bumblebee, for example, whatever, bees, grasshoppers. So these are different categories of the same class, right? So we have a general class, insect, that has the main attributes of all the insects. Then we have special attributes for maybe bumblebees, maybe grasshoppers. Think about any other insects that you may include. So what makes the grasshopper special compared to the bees? It jumps, right? Well, how about bees? Well, they make honey, they sting. So these are private attributes to bees over grasshoppers, and vice versa, jumping also for the grasshoppers over bees. You may find similarities in classes, but the general type here, or the general class here, lists all the general characteristics or attributes of the same general type of insects. All right, so this is what I said earlier, is a what? So is a relationship is quite general actually in inheritance. I'll just get back to the example I said about, which is a student. So university student is a student, right? High school student is a student. Primary school student is a student. So is a relationship. Let's get back to this one. Grasshopper is an insect, right? Bee is an insect. So this is the idea. Is a relation. That means we have a general type or general class, and then we have a special or some special classes. All right, that's exactly what it means. You may think about also a rectangle is a shape. This is possible. Circle is a shape. Okay, or whatever you think about from our life, it's possible. For example, Python is an object-oriented programming. It could be not, it could be addressed from another aspect other than object-oriented, but still it can be object-oriented. Java is object-oriented programming. C# is object-oriented programming. C is structured programming, for example. So in that case, if you want a bigger picture, C is a programming language. Python is a programming language. So we have programming language as a category, is a relationship. And you can use this is a relationship for many, categories, specialized categories or classes in this sense, in our life or in our application and object-oriented. So this is the idea of inheritance, is a relationship. We have a general class, we call it superclass. Okay, sometimes we refer to it by base class. This class has the general attributes of certain category that we have in our world or in the technical field, and then we derive a class from it, or we extend its attributes and functionality to have another subclass or derived class, or what we refer to here in this case a specialized class. Okay, we may add attributes and methods based on what kind of specialized class we are creating. So it depends. The customization here totally depends on your application. So when we say a student, we may just put a name, maybe age could be also. What else? Maybe student number, maybe. Okay. Then if you want to have a category for university student, what you can add? Matric number, matriculation. You can add GPA. Maybe you can add the program or the department. Well, these are actually differ when we speak about general class student and university student, and you can customize it based on your own need. Okay. So this is the idea. Now think about any other type of general class and special class. For example, if we speak about vehicles or automobiles in general, well, we can have cars, maybe trucks, maybe SUVs. This is possible, right? It's possible. And how about the private attributes that we may add? Think about cars, for example. You may add the number of doors. Truck, maybe you speak about specific type, or maybe the strength of the engine, for example. SUVs, you may think about passenger capacity or whatever. So it depends. When you want to customize, that means when you want to go special, you have to think about what's special in this class, so that we extend the functionality of one general class and we go to a special class. Okay, how do we create it? Now we spoke a lot about theory related to generalization and specialization. How can we create it? In Python, we know how to create class keyword, and then class name, and then colon. We start creating our class scope. But if you are inheriting, or if you are extending a class, you need to provide it inside parentheses. What does it mean? Let me show you. I'll just give you directly to this automobile I created. Is very similar to the example that we are discussing. We know this class automobile. Now we have a general class. What do we provide here in the initializer? Our constructor, we receive self by default and the make of the car, for example, or the vehicle. Now I don't want to say car, the automobile, the make, and the model, the mileage, the price. You may think about any attribute that you are interested in adding, or if if the solution or if the problem requires that. So in that case, we can initialize them, and we spoke about the initializer, whether we will need it or not previously. For normal applications with no inheritance, you will not need an initializer. It's not exactly necessary, but for inheritance, in this case, you will see why we need it. Okay, so now I initialized all of them, and you could just ignore initializing them, by the way. Why? Because we have setters. Setters can also initialize them. So you can ignore all these to be received here. You can just ignore it, and you can initialize from this side. However, this is like a practice. It depends actually on your need. If you want to initialize while you're instantiating an object from automobile, for example, you need to provide them. Why? Because they are required by default as an argument in this case. These are arguments. If you ignore them, remove all those and remove those, then you can set them up from here. However, let's say at the beginning you set them up, then you change your mind. You find that you made a mistake in the make or the mole or the mileage. You can reset them again, and you can get the make and the mole by these methods. We explain about them. Now, this is not our point. Our point is here. This is our generic class. It has all these attributes: the make, the model, the mileage, price. Let's say I want to speak about car in specific from automobiles. Okay, so what I'm going to do, I will not just create a new class totally, I will inherit this class and extend its functionality. So in order for me to do so, I create similar way of this. However, I encapsulate automobile inside these parentheses, meaning that it's the superclass of car. So I'm extending its functionality. This is the format that we are supposed to use. All right. Once we create this header line, then we need to do the first thing is to call the initializer of our own class, car. This initializer is the one used for our own class, car, not the superclass. So this is the subclass now. Now look at the private attribute I added, doors. Let's say we check the number of doors of the car for some reason, okay? Next to that, I have to call the superclass's initializer. So in order for me to do so, I need to use the superclass's instance, not my own class's instance. My own class's instance, or add reference of my own class's instance, is self. And that's why we use it self.door, self.whatever. But here, automobile.init will take us to where? To this superclass. Meaning that now if I instantiate, now I save this in one class, in one file. I call it automobile, or maybe I call it vehicles, for example. It doesn't matter. Now I can instantiate any of these two. It's possible. You can instantiate automobile. It's possible. I have created an initialization here, I guess. Yeah. So I imported the automobile as a, for example, whatever name, maybe you can call it automobile, auto, for example. Then you can use this name. You can create an instance automobile, maybe auto.automobile, and then you provide all these arguments, and then you can, let's say, get mileage, get whatever. So it's possible. I didn't put any make. I don't want to promote any of the car models. Okay. So let's just save and run. I'll show you this how it works. Now 0, the mileage is 0. Now look why the mileage is 0. I set it up to 0. I can change it. Let's say for some reason. Okay. Now I'll just print changing the mileage. Okay. And then what I'm going to do, I will call set. So my instance is auto, auto mobile dot set mileage, and then I'll provide here, let's say 20,000 kilometer. Okay, I don't have to write it in kilometer or whatever now in this case, and I will reprint this one. Okay, just reprint it. So let's just rerun and see. I'm not giving you practical, I'm just showing you so that see, changing the mileage, because we can still set and get the way we like since it is available to us. Now this file, I saved it as automobile, this one, the one I was in, has two classes, the superclass and the subclass. How about the subclass? Can I instantiate it? Yes, definitely. So let me show you how we can initialize it, or we can use it. I saved it in the same file name as I said. So I'm importing it as a, for example, or you can call it whatever you like. Now, I'm interested in cars, or car, not automobile, the general. No, I want this special. So car equals to the module that I created, a, and dot car, the class that we are speaking about, this class, the subclass. Okay. So in that case, what will happen? Oh, you specify the car model, make, and the model, the mileage, the price, and then the number of doors. Okay, one new attribute. And if you want, you can use, you can call whatever method that you like for setting or getting and see the outcome. Let me just run now, see 0 and 5. What is 5? The number of doors. I just made it plain. So that's exactly how we deal with such, an application that allows us to specialize in classes. I hope this is clear enough. So we need to call the superclass's initializer. We need to use its own instance, which is already sent to our class, and then reach out to the initializer of the superclass and pass all the arguments the way they are, just pass them, okay? And in the subclass, we need to initialize all the superclass's arguments and whatever extra we have, okay? How does it look like in the UML? So you have an idea about the UML diagram. The UML is actually representing classes in boxes with their names top, then the private attributes, then the methods. Okay, so now this is our superclass, the automobile with the make, model, mileage, price, and they are private. As you see, we have these double underscores. Then we have the initializer with the make, model, mileage, and price. Then we have the setters and getters. Okay. Now the idea is, I didn't create those. You can create them, specialize them the way you like. We'll speak about other examples, but we created this. Okay. What is special about cars not available in the automobile? Doors. This is a private attribute. And then we have its own initializer that initializes, other than the make, model, mileage, price, also the doors. So we have also another method, set doors, get doors. The rest of methods here are available also for cars. Why? Because they are inherited. By default, car can access to them, okay, with no problem. All right, so this is the idea. If you want to specialize another class and extend the functionality and the attributes of automobile, you can use it for truck. You can customize drive type or passenger capacity for SUVs and etc. So this is the idea. I don't want to extend it anymore. We will have practical later on. Polymorphism. Polymorphism is the idea actually of creating different forms or having different forms for the same object. And in Python, we speak specifically about actually having different names, having same name for some functions or some methods in this case in both superclass and subclass. What does it mean? It means my object or the instance of some class that's a subclass may have to override a method in the superclass. What do you mean by override? Overriding means what? Revoking the functionality of a method and placing another functionality. Now let me just get back to the slide here. When we place this automobile and we said car is a special class from automobile, or it's actually the extension, which is a subclass for the superclass. We said we need to call the superclass's initializer. We used automobile, then dot initializer, and we placed the the values there. That's exactly how we get to this superclass in this case. We are exactly overriding the initializer of the superclass in this case. And that's what we do in polymorphism. We may have a method in the superclass by certain name. Let's say set name, for example, or get name. And then we have the same method with the same name but different functionality. We customize the functionality, we customize the printout, the calculation if it is needed, or whatever in the superclass, in the subclass, I'm sorry, in the subclass. And in that case, what happens? If you are instantiating the subclass, you would be able to retrieve the subclass's method. If you are instantiating the superclass, you would be able to get the superclass's method or the version of that method. So we may have different versions for different attributes in this case, but for the subclass, it will override the superclass for sure in this case, and will not accept the superclass as one actually. Okay, it will just override it. It will have its own version of it. Okay, but for the superclass, if you are instantiating it, you can have its own version of that method. All right, what's the point? Why do we need to do it? Now, in simple words, you create a general class, and you may just set up some methods inside with either no functionality at all, or just simple functionality. And then when you specialize, you come up with these functionalities. So you don't have exactly a view about what kind of a number I give to a student in general. Is it an enrollment number, or is it the national ID, or what is it, the number that I give to a student? Well, how about we keep it empty until we reach to the special classes, then we think about the identity that we will give. So if you think about university students, they have their own matriculation. By high school, maybe you use the national ID or whatever, maybe they have school ID, etc. So this is exactly the idea. And that's why we override methods in the superclass by creating their own version in subclasses. We did to the initializer, and this is by default. It's done by default in inheritance. So if you are inheriting a class, you need to call its initializer and pass your own version of the info, the private attributes. Okay. Now, sometimes when we create different objects and try to reach out to their own methods, we get a problem with the proper attribute. Which one? Which is which? This instance belongs to which class? Is it an instance of class A or class B or class C, especially if you are dealing with many classes? So you may get an exception with which is attribute error. And in that case, to avoid such a thing, either you create a try and except, so exception handling mechanism, or if you don't want to do that, you can use isInstance. IsInstance is what? Is a function that allows you to check if certain object is an instance of a certain class. So for example, if you want to check whether car is an instance, or let's say earlier we said, let's say car1, if it is an instance of class car, so you provide car1, is it an instance of class car, it will return to you true if it is true, otherwise to return to you false. So before applying any like maybe override or any procedure to any class which you are not instance which you are not quite sure about its origin, which class it's coming from, which instance, or it belongs to any class, or which class it belongs to, you can apply isInstance. You provide your object and class name and see if it belongs to that class or not. And we will see it in practical, I mean during its session, in the practical session, not to extend this theory part. Actually, this is the end of the chapter, and it's not very long. We discussed the generalization of classes and the inheritance, where we spoke about the is a relationship, sorry. We spoke about subclasses, superclasses, or what we call derived classes, and the superclasses in this case, general classes. We spoke about also how we can create the rhythm or the design or the scenario of inheritance in practical, how we pass the whole class name inside parentheses as an argument to the class, to the subclass, and then we override its own or the superclass's initializer while creating first the initializer of my subclass, providing the private attribute that's missing or that we need to add, then overriding the initializer of the superclass, and then creating our own customization. We spoke about polymorphism, and we said that the ability of an instance or object to take different forms, where we spoke specifically about overriding methods. Overriding means what? We have a method in this superclass, we use the same name of the method, but we just customize same name and the same also argument list, but we customize the functionality of that method. That means if it is a display just printing out, maybe we print out another version of that method. If it is calculation, maybe we override the calculation as superclass, we create another calculation, and so on. And we said we may get into trouble with the proper attribute if it is attribute, if this attribute or the class or the instance belongs to certain class over the other, or belongs to class A, not B. So we can use the function is instance to determine whether it is an instance of class A or not, or class B or not, and based on that we will just skip the exception that may generated due to the attribute error. And that's it for this chapter. Soon enough I'll create a practical session where we will discuss some practical examples. Until then, have a good time.